Greetings student, welcome back, and let's continue our question. Figure 4 show a ticker tape of 16 cm. What you need to know is usually they already give you 0.02 second, 0.02 second. So usually one dot is 0.02 second. So usually the mistake that students do is they calculate how many dots. So they calculate 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if you use 11 times 0.02, you will get wrong because it is not 11 seconds. Because you need to time the in between. For example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's supposed to be 10 times 0.02. So 10 times 0.02 will be the total time. If you use 11 times 0.02, you will get wrong. You use 10, you get correct. Because it's from point A to point B, 0.02. Point B to point C, 0.02. That's why I draw the U. So next time maybe you want to draw the U to calculate the total time. So we can see that there is 10 dot here. 10 times 0.02, very easy. We already got the time, which is let me choose what color I want. I never use pink before. Use pink lah. 0. So if the total time will be 0.2 second. Oh my goodness, I need to change color. I cannot use pink because I scared of pink, a bit phobia of pink color. Let me change. Oh no, how to change this? Oh my goodness. Okay. Last time I eat medicine always see pink color. Now I see pink color also scared. Okay, determine the velocity of the time. Velocity will be displacement. We already learned displacement divided by time. So velocity equals to displacement divided by time. So displacement is 16 cm. Do I want to change it to meter first? No need lah. No need lah. 16 cm divided by the time. I do shortcut a bit lah because we already do times 0.02, you will get 0.2 second. 16 divided by 2, 0.8 cm as negative 1. Sorry, 0.8 pula. 80 cm as negative 1. So this will be the answer for the velocity. Of course, if they ask the speed, I will still do the same thing. For the speed, I will still get back the same thing. I still get 80. Determine the acceleration of the determine the acceleration. So I will say that this acceleration is a constant acceleration because you can see here is 0. I mean all is the same. So actually it's no acceleration. No acceleration because all the dot is equal. Because if high acceleration, the dot will be like this. From slow to fast. If the acceleration becomes slow, it will be far, then near. Okay, so the thing slow down. If no acceleration, it will be all the dot is the same. So we can see here all the dot is the same distance. So I will say there is no acceleration because what? Because I would say that because you can say that the speed or the velocity is constant. Okay, because here all the velocity is the same velocity, same, because all the dot is the same size. Or let's say you want to say because again, okay, there's no acceleration because the velocity is constant. Let's say 4 mark, the velocity is constant because for every 2 dot the distance is the same. So let's say it's 3 mark. Okay, let's say it's 3 mark. Again, I tell the first mark, the answer will be there is no acceleration. Why no acceleration? Because the velocity is the same when the object travel. Why the velocity is the same? The velocity is the same because for every distance between the 2 dots is the same. Therefore, when you divide it towards the time, you still get the same number. So that's how you do it. I hope you can understand why the velocity is the same. Velocity is the same because the 2 dot is the same. You use distance divided by time. Let's say you get here is 2. You use distance divided by time, you get 2. Distance divided by time, get 2. So all of you get the speed of 2. So there's no increase in speed. There is no acceleration. There also is no decrease in speed. There is no acceleration. Okay. So I hope you can understand what am I talking. Not I'm talking and talking to myself only. Figure 5 show two wooden blocks P and Q are different in sizes but the same mass. P and Q. So I want to ask P and Q, which one is heavier? Yes, very good. If I ask which is heavier, both are the same. If I ask which one is higher volume, so it will be P is the higher volume. And then I want to ask is let's say I ask which one is more density, so it will be Q have the higher density. But I don't want to go too deep lah, but you must understand, especially for Form 4, Form 5 science, at least we know that same mass means same weight. So same mass is 2 kg, the weight also 200 Newton, 200 Newton. If 4 kg, 400 Newton, 400 Newton is the same. Because you take something, maybe this is metal, maybe this object is wood. So of course metal is heavier than the wood, something like that, because the mass is the same, because the question already say mass is the same. Okay, let me erase. Very messy. Later I am also confused. Wait. Okay, let me erase this. Okay, now I have a clear mind what I'm going to do. Wait, still got this thing. Okay, give the meaning of the inertia. So inertia you already learned in the textbook. Okay, so we already got the answer. Inertia, what does it mean? Inertia is the natural tendency of the object to resist any change of its original state, whether it's at rest or in motion. So I already underlined the keyword, and previously we already learned what is inertia. Second question, which block has higher inertia? Explain your answer. So of course, I would say both is the same. Both is the same because both mass is the same. Okay, if you because since it has the same mass, so it has the same inertia. Let's look at if you still remember what we do, we learned that the inertia, relationship of inertia and mass, the higher the mass, the higher the inertia. The lower the mass, the lower the inertia. But now you are saying the same mass, because the question already says same mass. So of course same mass then same inertia. Okay, so it's a trick question. Is there any example? One big and one small inertia. I cannot think of any example. Maybe I can think of is I take the block and throw at you. Eventually the energy, I'm saying energy, energy that you block, let's say people throw P 5 kg at you, you block, and people throw Q 5 kg at you, 1 kg lah, 5 kg too heavy, 1 kg P of you, you block, people throw Q, you block. So the energy for you to resist the change is the same. You still block the same energy. You don't say that P I use more energy, Q I use less energy, or Q I use less energy, P I use more energy. It's the same energy that you block. But if I say which one is more pain, then of course Q is more pain, not P, because the surface area is smaller. This one we haven't learned now, but I just talked a bit lah. Because of the small surface area, it will higher pressure. So even though both the same, Q have a higher pressure, so your block Q is more pain, because Q has the same inertia, same speed, and because it's smaller, that's why you see the bullet is very small, because small, not only small, in front of the bullet is very sharp, so it's a very small surface. So when the small surface, if you get even small like bullet and you throw, people block out, people die lah, not block, because it's a even though the mass is very small, but the surface area is very even smaller, then it can create a more impact. So of course if you block Q, is more painful than you block P because of the surface area. But we are not going to do this. I don't know whether we got learn force or not and the pressure, but for now it is good to understand that both have the same mass, both have the same inertia, because we already learned in the textbook. State the first law Newton of motion. Okay, so first law, let's say first law is it out in our notes. Okay, so already got first law. Newton first law motion state that object will remain original state being at rest or motion at constant speed or motion if no external force act on it. So that is a law. It's not a theory, it's a law. Law means macam correct already. So it stated that it will either stop or it will move forever. We all here state it will move constant speed in a straight line unless there is external force acting on it. But you say, hey, I throw something, the thing will stop. Yes, that is the external force. Because when you throw something, the thing drop, there are two forces. One is gravity, pull the thing down. One is the wind. The wind will blow the thing, so the thing fall down. But if I throw in the space, like the moon and the star, I throw, it will forever go to infinity and it will never stop. That's why we say first law of motion. When you put something move, it will move forever. When you put something stop, it will stop forever unless external force acting on it. So of course, even you throw in space, I believe one day it will move a bit because of gravity. Many planets got gravity, so it will move a bit. Maybe is it true? It will move a bit. I think unless no force lah. If force, then I don't know whether the gravity will reach there or not. So it will move forever in a straight line. But sometimes I wonder whether in space something stop, it really means it stop, because we don't really able know it. That's why Einstein said that we know that it moved only because of the background. because if you don't see the background is moving, it's not moving. I mean the background is moving, so you thought it's moved, but if the background don't move, then we thought that the thing is stopped. So makes me wonder sometimes whether are we moving or not moving in space, because we live in the Milky Way and the Milky Way is spinning. So even though it's the Earth on the Sun, but eventually in the Milky Way we are moving or we are not moving, or other things are moving. Which one is the center of the universe? So that's a very unique thing. So so answer back the question. Object will remain original state, rest or motion until and unless external force act on it, then only it will stop. Okay, so let's say again, if here is 20 Newton, this is the law of momentum. You want to stop it, you still need 20 Newton to stop it. Exactly 20 Newton. More than it will go to another direction. So there is an additional thing that you can know. So that is the law of Newton, first law of Newton. Okay, last question. Figure 6 show a coin falling simultaneously in two cylinder tube. So this is the coin. Cylinder R is where figure 6 is a coin and a feather fall in a transparent cylinder tube. Cylinder R and S contains cylinder tube R contain air contain vacuum. So this one already show you in the previous video. If it is vacuum, both will fall at the same speed. If one is vacuum, one is not vacuum, then it will affect the weight. I mean the weight will play a role. Let's say like now I take this handphone and this drop, this handphone will drop faster, because this one when it fall down, it got the wind resistance, the wind block more. This one the wind block less. But if I put in the vacuum, both will fall down at the same speed. Okay, what is mean by free fall? What does it mean by free fall? So let's look at the notes. Free fall. Okay, free fall is what? An object is said to experience free fall due to the effect of gravitational force only. Okay, so if we are talking about gravitational force only, we are referring to a free fall. Maybe take away the wind. Okay, so there is no wind when we are talking about free fall. Okay, continue on. Compare the time taken for the coin and feather in R and S. So R got the air, S got the no air. So compare the time and explain. So we need to compare the time first. So we compare the time, we can see the feather up here, the coin down here. Compare the time and we explain why. And then we can see that the coin and the feather like together, the time and then why. So we get the data for R, we say Y. We get the data for S, we say Y. So for this question, I can give 4 marks. So why don't you can try and think in your mind. Okay, so let's see. I hope that you can. Okay, so first we explain Y for R first. Don't be scared by the question. We say by R first. Wait, I just keep. I take an empty box, so I got place to write the answer. I just put down here. Okay. Okay, mark up. Take the take what pen? Well, I choose blue and black. Is there any color I can choose? Maybe some dark green. Where's dark green? I'm a bit colorblind actually. Where's my dark green? This is dark green, is it? Oh my goodness. Okay, this one. Okay, time taken for the coin and the feather in R. So let's talk about R first. In cylinder R, coin fall down faster than the feather. Because what? Because there is air resistance. Because the air block the feather. Because feather got big surface area, so it will come down fall. The coin will fall down very fast because it has a smaller surface area, and also then it will fall down lah because of the smaller surface area. If this coin I want to make it to very big, the coin also will fall down very slow. You just make it like you press the coin until like very big paper. Then the coin also fall very slow. Even though the coin has the same mass but the surface area. So eventually we say that the coin fall down faster than the feather, not because it is heavy, because there is air resistance. The air is blocking the coin. Yeah, you cannot say it's heavy. Then you say, but in physics, we really cannot say the thing is heavy, okay? Because it does not really matter. The speed is still the same. Let's do on R. What happened in the R? Okay, in R, we can say that the feather and coin drop at same time. I'm not saying maybe at same speed lah, same speed or reach the ground at the same time. Because what? Because there is no air resistance. Since this one I add myself, it is vacuum. So since it is in a vacuum, you will drop at the same speed together, and it doesn't mean that you are heavier means you will drop down faster. I mean, yes, you are heavier, you drop down faster in the sense that you got less air block you. But the thing is, if I cut the coin until like a sand and I throw it, the coin also drop very slow. So I don't say that because it is heavy, because it's still the same sand ma. Sand heavy or not? Sand is heavy. I just cut the coin ma. I cut it until become the sand. I throw it. Maybe the feather fall down faster than the coin. I cut until very small, very small. I throw the coin. You say coin is heavy ma? Oh, now then why is it? Then you say it's sand. Sand not heavy, but it's the same thing, right? I just throw up on it. But because we say the air resistance, so you can see the keyword is the air is blocking the thing, not because of the object is more heavy. So I hope that you can understand this. Yeah, because you already see the experiment you can do if you take out the vacuum bulb dot at the same speed. If you go to the space, let's say this is a black hole. This is a black hole. I put a planet here going to the black hole, and then the feather, a very small feather going to the black hole. Both will go at the same speed because of the gravitational of dragging it and a free fall. So probably both is the same speed, unless this is an additional unless the object is very big, because we learn in science, the bigger the object, the bigger the gravity. So we see the sun is big, then it got more gravity. The earth is small, less gravity. Our moon is even smaller, so less. So the bigger the mass, the bigger the gravity, and bigger sun, even bigger gravity. And black hole is, you know, the dying sun that actually compressed because it's too big and compressed to a singular point, so it become very heavy. So the gravity is very strong. So yeah, so it's not because of the thing is heavy, okay? It's because of the air. create a suitable conclusion for the activity above. So how to do this question? Conclusion. Okay, this is not easy, macam easy but not easy. First, we need to know conclusion for every experiment depend on the hypothesis. Means what you want to know. When you do the experiment, you just read this question, you cannot answer. You need to ask yourself, when I do this experiment, what I want to know? What I want to know. If you read the question, you can see the MV and the RV, manipulated variable and RV. So can we see? Wow, he also didn't write. It is not easy. Okay, but let's try to find the MV and the RV. So the NV and the RV, we can say that the NV is the presence of air. And then the RV, I will say the speed of item falling down. So I can say that if there is air, it will the speed of the higher the speed of the coin will be faster than the feather. If there is no air, the speed of the coin fall down is the same. But I cannot say that in the exam, because actually what I want to talk about the MV is the free fall. The MV actually is also the free fall. But I cannot test just free fall. I need to use air and no air. So for the conclusion, we can say that how does the free fall relate to the vacuum and air resistance? So I will say that if there is no air resistance, the object will experience free fall. Okay, if there is no air resistance, the object will experience free fall. This question not easy. I also until now I also don't know how to explain, but we need to know the concept. The concept is when this guy tried to do this experiment that time, maybe from the picture we can know that maybe he want to study free fall. So he take one got air and one no air. So after he finished the whole experiment, he said that, okay, now I'm the scientist, I already proved to you that if there is no air resistance, the object will be free fall, because free fall means is the gravity will act the same on every object. Okay, so that's it. Okay, so if no question to ask, I hope that you can understand. If you don't know, you can leave in the comment below or WhatsApp me. So I see you next time. Thank you and bye bye.
Thank you, teacher.
Thank you. Bye bye.